Hello, MeasureSummit. It's a pleasure to be back on this virtual stage once again. I hope that you're having a great time, and now let's talk about data accuracy. Before we begin, I wanted to give a quick disclaimer. In this presentation, I will not be talking about consent. If a visitor comes to your website, does not give consent, then you don't track that visitor, or maybe you track some limited data, but that's it. You will still end up with losing some portion of your data, and that is the reality that you just have to accept. However, there is a bunch of other areas where we have some sort of control and we can improve them. And this is what I will be focusing in this presentation. Many of us have spent years working with Google Tag Manager and Google Analytics, building these incredible setups, these data fortresses to drive business growth. But like any fortress, they are not impenetrable. And today I wanted to take a look at some ways how can we reinforce those walls. Looking at potential challenges that we have with our setups, I decided to split those challenges into three groups. We have external challenges like intelligent tracking prevention, browser extensions. Then we have internal challenges, bots, who are like spies that want to infiltrate your data fortress and compromise your data. And then there are many ways how we can accidentally misconfigure something and add weak spots to our walls. This is our modern data battlefield. So what do we do? Let's start with external challenges. When we look at the setup of Google Analytics and Google Tag Manager, we can think of three levels of the setup. The first one is the basic one. This is the one that we get out of the box. When you create a Google Analytics property, it asks you to add a Google tag on your website. It might be a G tag code added to your website, or it might be a Google tag added with Google Tag Manager. Even though this is a simplest option, it is the most limited because it is most vulnerable to various external factors. Browser extensions can block those requests. Some browsers might limit the lifetime of cookies. So on this level, your setup is least accurate. Then we have the next level, which is Google Tag Gateway, which was previously known as first-party mode. Basically, what happens here is that when you enable Google Tag Gateway, you start loading Google Analytics and Google Tag Manager through your own domain. Let me quickly explain how that works. So we have a browser, and your website is loaded in that browser. The content is loaded from your website server. So if you are using a content delivery network, for example, Cloudflare, all requests are going directly through it. So with Google Tag Gateway, you can use the same content delivery network to also load a Google Tag and Google Tag Manager container. So instead of loading directly from Google servers, first that request goes through your CDN, which means that a request to Google Analytics could look something like this. Instead of having googleanalytics.com, you have your domain.com, then /something, and then the request parameters that describe what kind of event happened. So where does it help? In this case, fewer browser extensions will interfere. Of course, not all of them. The ones that are more aggressive, they will still block your request. But in this case, fairly easily, you can still improve your data accuracy at least to some extent. Because for example, if you're using Cloudflare, enabling Google Tag Gateway takes you like 5 or 4 clicks or something like that. But it is still important to understand that there is a handful of extensions that will still block your requests related to Google Analytics. That's why you should look at level number 3, which is server-side tagging. In this case, we are not only proxying, or in other words, loading Google Tag Manager and Google Analytics through your own domain, but we can also do some additional tweaks. So if you have the right skills and some budget, because server-side tagging requires servers, which cost money, then definitely you should choose the level 3. But if you don't have any budget, then as a limited workaround, Google Tag Gateway might be an option for you. So now let's take a look what happens when you are on level 3. You have Google Tag, you have Google Tag Manager, you're using content delivery network, but there is one more component in this chain, which is your server-side Google Tag Manager container. If, for example, you're using some specialized server-side Google Tag Manager hosting provider like Stape, then you can enable certain features that will make your requests from this to this. Because some extensions, they are looking not only at your domain of the request, they are also looking at request parameters. For example, if they see TID, then equals G, and then your measurement ID, they can still flag it as related to analytics and they can block it. But if you're using some custom loaders that obfuscate the entire request URL, then your setup will be much more resilient to the impact of browser extensions. So where does this help? Well, first of all, even more extensions will not be able to block the requests, therefore you will get more data and your data will be more accurate. Another huge benefit if you are using server-side tagging, and especially if you're using it in the same origin context where you have your own domain / something and then the request parameters, then the IP address of requests related to website content and your analytics will be the same, which means that if you set cookies from the server, their lifetime will be expanded. Instead of having cookie lifetime of 24 hours or maybe 7 days, you can have 1 month, 3 months, and so on. So as you can see, the benefit is much greater compared to the level 2. However, it also requires more technical knowledge. So this is not something that you can achieve in just a couple of clicks. So if you haven't used server-side tagging before, then definitely investigate things like proxying and same origin setups, which will help you reduce the impact of browser extensions and also limitations on first-party cookies. Then we have internal challenges, bots. So let's take a look at some approaches how you can reduce the impact of bots. Now, I want to emphasize here is that, in my opinion, there is no single solution that can completely get rid of the bot traffic. It always comes down to the mix of tactics that you can apply. I will list multiple options, so if you try to implement at least several of them, then the results will be better compared to having just one of them implemented. And don't be afraid to experiment. Try one option, then if it does not show good results, try another one. I decided to split tips of this section into 2 groups. The first one is what you can do if you're not using server-side tagging, and then the other one will be what you can do with server-side tagging. So the first tip might sound obvious, but I still see sometimes websites that are not using it. In fact, this first tip is not even related directly to Google Tag Manager. If you are working with a website and that website is visited by people from various parts of the world, then you should be using Content Delivery Network. And Content Delivery Network is not responsible only for the improvement of page loading speed. They also usually have some anti-bot features. For example, in Cloudflare, you have bot fight mode that you can enable, or maybe it is enabled already in your setup. Since Cloudflare is one of the most popular content delivery networks in the world, they have a lot of data and have various ways to identify bots and distinguish them from real people. So if you are suffering a lot from bots, then try to enable anti-bot features, and you should notice at least minimal improvement in your data accuracy. Because if bot is blocked completely, it means that the bot will not load your website, will not load your JavaScript, and obviously it will not load your Google Tag Manager and Google Analytics. So your numbers will not be as skewed as they could be. Or maybe you're not using Cloudflare, maybe you are using a different CDN. In that case, investigate what kind of features do they offer, and if they are not enabled, do that now and see if over time your numbers become at least slightly more accurate. Another option for you could be to check for headless browsers. Simply put, headless browsers are browsers without an interface, and bots usually use them. So as a proof of concept, I used a code found online, and it's not very comprehensive, but it does the basic job. So if this variable returns true, then most likely that browser is headless. And if it returns false, then most likely this is a regular browser. In fact, you could even make this code much more comprehensive. You could use ChatGPT or Gemini, and I've tried that, and they check other things to verify whether the browser is headless or not. So you can definitely do that. Look at this code as a proof of concept. Again, I found it online. I don't remember where I found it, so sorry for not crediting the original author. So how can we use this code and benefit from it? Well, what I would suggest is that you can use this variable and send a custom dimension with all your Google Analytics 4 events. Then, once you do that, you can collect data for a while, and let's say after a week or 2, you look at your reports. For example, this one. Here I am comparing visitors where headless browser is false, and I look at how many views did they generate, and also how many key events did I get. Technically, you could add more metrics here, but for proof of concept, I think this is enough. And as you can see, those sessions or those events where headless browser was true, the number of key events is significantly lower, which could imply that this is indeed a very low quality traffic. Even though the percentage of headless browsers is not very large, and I would probably not fix all of my bot problem, this can still be a somewhat of an improvement compared to the situation if I was not using this solution at all. So if you implement this, you collect data for a while and you see somewhat similar results, then you could update your Google Tag Manager tags to not fire if headless browser is true. So in this case, I could get rid of around 1% of entire traffic because I think this is a bot traffic. An example of a trigger could look like this, where you add an additional condition and you're checking that headless must be equal to false, which means that the browser is not headless and this trigger should be activated. If you choose this approach, then you will need to add this condition to all your triggers where you want the tags to fire only for regular browsers. But if you have hundreds of tags, this is not very scalable and it will require a lot of manual work. So alternatively, you could create a blocking trigger where the condition is that you first enable regex matching, you enter .*, which means any event, and here you're looking for headless browsers. So headless equals true. And then once you create this blocking trigger, then you could use bulk editing in Google Tag Manager and add that blocking trigger as an exception to all tags. So basically you could achieve this with technically like 10 clicks or so, rather than updating all your triggers manually with the headless condition. Then the next tip is not proactive, it's more reactive, but I think it's still worth mentioning, and that is IP exclusions. If your reports look something like this, where you have sudden spikes in your data, then it's likely that these spikes are caused by bots. In that case, you could cooperate with a developer and ask him or her to check the server logs. Maybe those requests are coming from a particular IP address, or maybe several of them. Maybe there is some crawler of one of your SaaS tools that regularly scans your website every week or so. Chances are that maybe indeed these spikes are coming from just a handful of IP addresses, and you could include them in your Google Analytics 4 property. You create a filter. First, you could define it as internal traffic, and then you could create a filter for that to exclude this kind of traffic. In a nutshell, the setup process would look like this. After you have identified those particular IP addresses with a developer, then you will need to go to the data stream settings in Google Analytics, select define internal traffic, then create a new condition there where you list the IP addresses, and then here you could add a particular value of the traffic type. Since we're talking about bots, then I will enter bots right here. Once you save this configuration, then you will need to go to the data collection settings of your GA4 property and go to the filters. Create a new filter where the filter operation is exclude and traffic type is bots. It must be the same as it is right here. So basically what will happen is that when Google tag is loaded on a website and Google sees that the visitor is coming from one of those IP addresses, it will add a traffic type parameter with the value bots. And then this filter, if it sees traffic type bots, it will exclude that event. And that way you will be able to reduce the impact of those spikes at least a little bit. Of course, keep in mind that retroactive data will not be affected, and if the IP address of those bots eventually changes, then you will start seeing the spikes again. So all of these previous tips would work even if you don't use server-side tagging. But if you have SGTM, then here's what you could do as well. So first of all of the previous tips still apply. You can implement them, you can try them and see if they help. But with server-side tagging, you can take the next step. For example, you can use reCAPTCHA. Simo Hava a while ago has written a blog post where he explains how to integrate reCAPTCHA and get a bot score for each request. And then if score exceeds a certain threshold, you could block those tags from firing in your server container. Alternatively, you could try to use bot detectors. For example, if you're working with Stape and you enable their power-up, which is called bot detection, I think, then with each incoming request in your server container, you will also have the bot score. The maximum of this value right here can be 100. And if it is, then it's most likely bot. So what can you do here? Well, I think it could be the same approach as it was with the headless browser. First, you could send the bot score as a custom dimension to Google Analytics. To do that, you should create a request header variable that will fetch the value of the bot score of each incoming request. Then you will need to update your Google Analytics tags in the server container so that they include an additional parameter. Let's call it bot score, for example. Its value should be the header variable. And then finally, once you do that and publish in your Google Tag Manager container, you should register an event scoped custom dimension. So if the parameter that you send is bot_score, then the same value should be included right here. Then after collecting data for a while, you could build a report and look at the data where bot score is higher than something. For example, here I have a bunch of views, no key events, and the bot score is very high, which means that these are most likely bots. If you see something similar in your case, then you can decide what is the acceptable threshold. For example, if bot score is higher than 65, then you could block your tags in Google Tag Manager from firing. The reason why I do this validation process is because it gives me a better idea of the traffic quality, and then I decide what is the arbitrary threshold when I will start blocking certain tags. And then the third group of challenges: weak spots and cracks in the walls, also known as misconfiguration. Now, let me get this straight. There are thousands or probably millions of ways where things can go wrong. Maybe certain feature is not enabled, maybe something is not clicked, or so on. I will not be talking about things like not set or unassigned or something like that. I have written a lot of blog posts about this, also recorded a bunch of videos. So if you have these kind of problems, then go take a look at my resources. In this presentation, I wanted to mention two not that common problems, but they can still mess your situation. Plus, once in a while, they reoccur in my feed, and I still see people doing the same mistakes. So maybe at least one of these tips will be useful for you as well. Here's a situation. I was contacted by one company, and they had a problem where most of the events and revenue and purchases, they were attributed to a single user. And they asked me, why was this happening? So I took a look at this, and first of all, I noticed that there is no user ID implemented, and their tags in Google Tag Manager looked fine. However, I noticed the @sign at the beginning of the effective user ID, which implies that this is somehow related to user-provided data. But when I looked at their Google Tag Manager container, I did not see anything related to user data. So what I did next is that I checked their settings of user-provided data capabilities. And in the admin panel of Google Analytics 4, I saw this. They had enabled the automatic detection of user-provided data, and they were looking for emails, phone numbers, name, and addresses. This particular feature means that when Google Analytics is loaded on a page, and if it notices some user data like email or phone number, it will automatically scrape it, hash it, and then send it to Google. So the question is, why was this causing so much misattributed events, and that data was assigned just to a single user? Well, I opened their website, I looked at their footer, and I noticed that they have contact information of the company in the footer. They had phone numbers and they had email address. As a result, when Google Analytics loads, it checks the content of the website, it notices email address, it notices phone numbers, then it hashes and sends to Google. But this is not user data. However, if you're using automatic detection of user-provided data, Google Analytics does not know which email belongs to the company and which one belongs to the user. So even though there are probably thousands of visitors coming to this website, they all get assigned the same email and the same phone numbers, which means that Google Analytics starts thinking that all of these different devices, browsers, they belong to the same person, which is not correct. So the key takeaway of this section is that automatic detection should be your last resort. Even in their documentation, Google says that you should prioritize other methods how to send user data to Google. By the way, a quick side note is that personally, I prefer not to use user-provided data with Google Analytics at all. If you're working with Google Ads, I would instead recommend using the native Google Ads conversion tracking and then sending user data that way. Because what I've noticed is that when you're using user-provided data inside Google Analytics, some things can go wrong and user counts might also not make sense sometime. But going back to this topic, if you decide to use user provided data capabilities in Google Analytics, because maybe you later import that data to Google Ads, then try to avoid using the automatic detection. Your number one choice should be to use the manual setup. For example, in Google Tag Manager, you can use a user-provided data variable where you select a manual configuration and then you insert variables where you have specifically defined user data. For example, maybe you have user email and then first name, last name in the data layer. That would be a great option where you can pick that data from. So this is the best recommended option. Then the second best option, even though not as good as the first one, would be to specify CSS selectors or JavaScript variables of that user data. In that case, Google Analytics will not blindly pick the emails and phone numbers of your website. Instead, they will pick data only from those elements that you have defined. And if that is not an option, then only as a last resort, you can look at the automatic detection. Here you can add some exclusions, but working with exclusions is not very scalable because if some new elements are added to the website and you did not know about that, then you might end up with the same problem where Google Analytics scrapes too much information or incorrect information. So if you decided to collect user-provided data, do that in the manual way because it is most reliable. And I mean, even in the user-provided data variable, we have automatic collection. But I, again, want to emphasize that ideally you should look at the manual configuration only. And then the last tip, which is not very common, but if you happen to find it in your setup, then this can definitely make no sense in your data and can mess it up big time. And that is related to the situations when you are tracking user IDs, but the visitor browses without being logged in. So here's one of the projects where I saw a situation like this. We have an event, let's say it's called user data, and together with that event, developers push the user ID. Then I can use that user ID and send it to Google Analytics. However, what I've noticed is that when the user is not logged in, they were still pushing the parameter and they were pushing it as a text. For example, it can be undefined, surrounded by quotation marks, or none, or not logged in, or something like that. So even though it might look okay because, well, the user is not logged in, so we are sending undefined, this particular approach is not correct because you're sending the word undefined, which means that Google Analytics will still think that this word stands for a user ID. So if your developers are sending text which has some negative meaning like none, not found, not logged in, undefined, and you're sending it to Google Analytics as a user ID, then GA4 will think that all of the different visitors who have not logged in, they are actually one user. And your reports will look like this, where you have, let's say, the event count and total users is 1. Because all of those not logged in users, they had the same undefined or whatever value sent as user ID. So how could this be fixed? Well, there are mainly two approaches. The first one would be to tell the developers that if user is not logged in, then don't push the user ID to the data layer at all. Which means that in this case, there should be no user data, or if user data happens, then there should be no user ID parameter right here. Because if that would be the case, then the tag in your Google Tag Manager container would still send the request to Google, but user ID parameter would not be included. Or another option could be to send undefined, but without quotation marks. In that case, Google Analytics tag in Google Tag Manager would also drop the user ID parameter from the request, and Google would think that this user has no user ID and that user is not logged in. Because otherwise you will have to deal with the nonsense data like this. So these were two misconfiguration mistakes that I wanted to mention here. They are not common, but I thought that they are quite interesting, so I decided to share. So if data accuracy in Google Analytics is quite a pain in the ass for you, and you want to get more tips, then I've recently published an ebook called How to Increase Data Accuracy in GA4. It includes more tips compared to this presentation. So if you want to get that free ebook, then go to analyticsmania.com/accuracy and get that ebook today. All right, MeasureSummit, thank you again for having me. I hope that you found this useful, and I hope that you will try to apply at least some of the tips mentioned in this presentation. Thank you.